Let's today understand about scalability. So scalability is a very important term, and you would definitely hear a lot about it when you are working in a software industry. So before going into the formal definitions, let's understand the concept, the problem behind it, and then how you basically solve that problem by different techniques, uh, and how you can make your system scalable. So taking a very basic example, so let's assume you are building a very basic website, right? So what you will do is you will install a database into your machine. So let's say this is your laptop, right? So what you will do, you will install a database into your laptop, right? You have some sort of a server, which is application server, which is taking the request, like Node.js or Spring Boot or something like that, and then you return the response, right? So these all things are hosted in your laptop. So laptop have, let's say, 8 GB and let's say 112 GB hard disk. This is RAM, 8 GB RAM. So let's you just deployed it as a hobby project. This is working fine. Let's say you have 100 users or 500 users, and you are receiving 50 requests per second. So your machine is working absolutely fine. Basically your website is working absolutely fine. Now let's say your user base increased. It goes to 150 requests per second. Again, it's working fine. Then let's say your app goes, or your website goes a little bit viral, and it goes to 300 requests per second. Now what your users start complaining is that website has gone a little bit slow. Why? The answer is very obvious, because you have your RAM as fixed, right? You're not increasing your RAM, but your request per second is increasing. So your concurrent resources need is being increased constantly, but you're nowhere increasing your hardware, right? So definitely some requests will wait while the others are processed, and then they will be processed later. So that's why your website is becoming slow. Now this goes to 3000 requests per second. Or let's say this goes to 10,000 requests per second. Then definitely there'll be a lot of complaints from your users that your website is down or it crashed. What it basically means is, for them, they are not getting any response, no response, right? Or they are getting 5xx errors, internal server error, something like that. So why is that? Because your RAM is constant, your hard drive is constant, you are continuously increasing the load. So your system is not able to handle few load, and some requests are basically rejected because they are timed out. So your website is not able to handle it. So this is the basic problem of scalability. With increased load, and that too concurrent, your system crashes. So that is the basic problem, or you could say your system is not scalable. So what you do is, you, like, very logical step, what you do is you increase the RAM somehow, right? So maybe instead of 300 requests, you are able to cater 600 requests efficiently. But there is obviously a limit. You cannot keep on increasing your RAM, right? Because first of all, it becomes very costly, and it cannot go beyond a point, right? So then you are stuck basically. So what you have to do is you definitely have to add new servers, right? So that's what is called horizontal scaling. So what you have to do is you have to have a cluster of machines. Instead of one machine handling all the load, you have different application server. This is called application cluster. So you have S1, you have S2, you have S3. So all these machines will have the same code, but they would be independently working, like physically they would be independent. And then in front of that you have a load balancer. We'll understand about load balancer more in detail later, but for now you understand that this basically distribute the loads to different application servers. And then you have sort of a database cluster. Again, here also you have different databases, right? So from this you came to this, right? Now, as with the computation as with the computation problems, you would have the same problem with the data, because as the number of users are increasing, your data will also increase. So it becomes impossible to have all the data stored in one machine. So definitely you would be needing different sort of database servers to store the data. We will understand more about how you distribute your data into different database servers, concept like sharding, replication, that will come later into the picture. But now, for now, understand that you cannot store all your customers' data into a single database server. You would definitely need a lot of databases spread across multiple geographies to cater your request. So another problem with this is, uh, let's try to understand what is the other problem. So there is something called single point of failure. So not now, let's understand now, not even if your request is not increasing, but again if your system, this laptop goes down due to some reason, your request, other requests are not available. So your basically your website is down. So even though there is not much traffic, but even in that case also you're not able to cater your traffic. So that is called single point of failure, which is called spoof. So with this architecture, you have definitely you don't have single point of failure, because you have different machines working together, and same with the database. So even if one database is down, your other database can definitely work on. Same with your application servers. So for scalable system, you would definitely need, first, avoid single point of failures. You would need to have distributed systems. You cannot cater all your requests into the single environment. You would definitely need distributed systems. So that's the basic understanding you should have for a scalable system. We will understand more how you can achieve it, but this is a problem statement. Now let understand uh, what is what are the different types of way we can basically scale our system. One is definitely, as we said, vertical scaling. When we increase our RAM, CPU, this is called vertical scaling, but definitely it has a limit, right? You cannot have, it has a limit. You cannot infinitely scale your system vertically. So definitely good for incremental traffic, If let's say your traffic it increase 1.2x or 1.5x, then this is fine. But let's say if it is increasing 100x, you have to definitely go for the horizontal scaling. So this is basically what is a rescue. And every system, when you talk about every big systems like Amazon or Flipkart, when there is a flash sale or there is a big billion day sale, they have to increase or add more load to your server, right?